Good morning, good afternoon, everyone. Thank you for joining us. We're just going to get started in a few minutes when we give people a bit more time to enter the meeting. Morning, everyone. We're going to get started in about 1 minute, just giving the stragglers a little extra time to log in this morning. Thank you. All right. Good morning or good afternoon, everyone, depending on where you're joining us from. And welcome to today's forum, Reducing Farm Equipment Risk Through Innovation. My name is Megan Truxell, and I'm the Director of Development at CASA, and I'll be your host for today's session. This forum is part of our Canadian Agricultural Safety Week and is proudly sponsored by the Canadian Canola Growers Association. For more information about Canadian Agricultural Safety Week and to access our media kit with numerous articles, PSAs, and information, please visit the CASA website at www.casa-acsa.ca. The link's also going to be in the chat. Before we begin, a few housekeeping notes. Today's presentation is being recorded and will be available on the CASA YouTube channel and shared with all registrants later this week. The format for today will include a presentation followed by a brief Q&A session. If you have questions during the presentation, please put them in the chat and CASA staff will be monitoring and will ensure that we address them with our speaker afterwards. It is now my pleasure to introduce today's presenter, Mike Senneff. Mike has spent many years contributing to the development of safety standards for agricultural machinery through both the American Society of Agricultural and Biological Engineers, ASABE, and ISO. He served for 12 years as chair of ISO Technical Committee 23, Subcommittee 3, Operator Comfort and Safety, and played a direct role in developing many of the international safety standards used in agricultural machinery today. A lifetime member of ASABE, Mike has served as a chair, working group leader, and member across numerous safety standards committees. He currently serves on the U.S. Technical Advisory Group to the ISO Technical Committee 199, Safety of Machinery, and is also a certified Fire and Explosion Investigator. Since retiring from John Deere, Mike continues to support the product safety and compliance community through his consulting firm, Product Safety Help LLC. Welcome, Mike, and thank you for joining us today.
Well, thank you, Megan. Thank you very much, and happy St. Patrick's Day to all my Canadian friends. It's just a real pleasure for me to be able to talk to this group. I know that those of you who have logged on here have an interest in farm safety, and I think that's just great. And I would imagine many of you have been raised on a farm. Some of you maybe not, but it's just it's good. I'm encouraged to see that there's an organization like CASA that takes safety on the farm up as a mission to change. So it's just a good time for me to be here. Just a little bit what we're going to be talking about today. I'm going to look very briefly at some farm fatality statistics and talk about those briefly. Then from a manufacturer's perspective, I want to give you a view of how manufacturers, whether they be large or small, generally approach the safe design of machinery and some of the steps and processes that manufacturers go through and why they do that and so forth. And just to give you an inside look of what goes on in manufacturing, I started with John Deere in 1976 at its combine harvester division down in East Moline, Illinois. And I stayed with Deere until 2010 when I retired. And most of those years I worked directly in the area of product safety. That involves such things as working with design teams, investigating accidents. Megan already mentioned being involved in the development of safety standards for agricultural machinery, all manner of things, advising design teams, doing risk assessments, and so forth. So in summary, what I'm going to be talking about today to you is what manufacturers typically do are things that I have done. Now, it's possible that there's a manufacturer out there that you may come across or be aware of that hasn't reached the same level that I'm talking about here today, and that's understandable. I've worked with companies that have asked me to come look at our product safety program and tell me what we're lacking, if anything. And sometimes I find things that are lacking, and those companies generally, as a rule, change their process or put a new process in place. So all for the benefit of improving safety of farm machinery. So here's just some of the things that we're going to be looking at. But to start off on agricultural statistics, this is an absolutely excellent article. Megan put me onto this website. We don't have, to my knowledge, a compilation like this down in the States. And I found this very interesting. It's a good read if you want to hear about read about what's going on with agricultural fatalities and injuries in Canada. This is a good one.
Sorry, Mike, did you want to share your screen so we can see that?
Am I sharing?
No, you're not. So I just wanted to.
Oh,
sorry about that.
Well, okay, let me go back here and figure out why I didn't do that right. Okay, share screen. Okay, here we go. I apologize. I should not have done that. Is that showing now?
Yep, you're good. You're on farm statistics now, so that's perfect.
Okay, very good. Well, in Canada, from the data that I read in the article, the previous article that you didn't see, but I posted on the slide, farm rollovers on tractors continue to be the lead accident fatality situation in Canada. It's very similar in the United States. Right behind that is runover. Between the two of those, they comply almost 30% of the fatality accidents in Canada, 8% for operators or bystanders being pinned or struck. The good news is that rollovers have been going down, according to the statistics, about 6.8% annually. Runovers down as well, and pinned or struck accidents and fatalities are up by 18%. I don't have insight into why necessarily that number is up or why the situation on why the incidents are going down. But it is a good trend. It's going in the right direction on farms. There is a caveat though, and I have included that here in the population of farms, the farm population, not just number of farms, but the number of workers and people living and working on farms it's taken a dramatic drop from 1990 to 2020. So you would think, well, with that loss number of people, less people working on farms, the accident rate should be going down more. Maybe yes, maybe no. But it is a trend for a farm population, the same in the US. Canada and United States are not, there's not much daylight between the statistics between these two countries. One of the, with rollovers being one of the barriers to farm accidents, fatalities, here's the reason why. And it's a challenge for farm safety organizations like CASA to overcome this, but it is the large number of agricultural tractors that are in the field that were manufactured before rollover protection structures were standard equipment on them, all essentially all mainline, all tractor manufacturers. That started, standard equipment started in about 1987. But these tractors stay out there for a long, long time. And I think if we dug into the statistics on individual fatalities involving rollovers, we would find out they would be older tractors like these. On the drive overs or the run overs, I would expect if we looked into a lot of those, we would find a lot of those, or a majority of those, being children riding on equipment and falling off. And you look at these tractors here, for example, the ideal place for a child, at least in a farm operator's mind, might be to sit on that fender, nice, flat, and horizontal. But those things, that's what Canada farm safety has to deal with these days, and it's a challenge. Before I get into what we do, I want to just explore just briefly what the primary objective of all the things I'm going to talk about that manufacturers do. The primary objective is to provide a machine, whether it's a tractor or a self-propelled machine or an implement, that does not present what's termed an unreasonable risk of injury. Unreasonable risk of injury, that is a term that's applied in the civil courts, both in Canada and the United States. And basically, an unreasonable risk of injury means that the user that was operating the equipment, that particular machine, whatever it was more dangerous than what that user expected. So, and the question is, would a reasonable person, in this case a farmer or a farm employee, would they recognize the risk of harm in a given situation? And so this is what gets debated a lot in the manufacturing industry as to what is an unreasonable risk of injury or not. And I'll give you a couple of examples. Back in the 1970s, early mid-70s, there was this game called yard darts. And I've shown a photograph on the left there. And this was a rather creative game. You throw a circle down, 2 circles down on your lawn. And the idea was to, from a distance, toss this dart that had a pointed end, a leaded, weighted pointed end, and try to get it into the circle. Rather creative way, maybe kind of fun, but the problem was there were too many accidents where those yard darts would miss the circle, go too far, and actually strike the participant on the other team in the head, with the darts going into the skull and so forth. That was an example of a toy or a game with an unreasonable risk of injury. The users didn't think that a yard dart, this simple plastic toy with a pointed end, could pierce someone's skull, but it happened a lot. And they were ultimately, I don't know about in Canada, but down here in the States, they were withdrawn from the market and made illegal. Over on the right, something more common, your simple walk-behind mower. People generally that mow their grass with one of these have a pretty good respect for the mower and what it can do. And they have an idea and a respect that if they're not careful, objects that they pick up in the lawn might be thrown out from underneath the deck of the mower and strike someone or strike them in the ankles or maybe a bystander. So that's not an unreasonable risk of injury. That's not more dangerous than what the customer or the user of the equipment expected. But they would not expect, for example, if there was a defect, a hidden defect in the mower, that allowed the blade itself to come off and come flying out underneath the deck and strike either the operator of the mower or a person nearby. That would be considered an unreasonable risk of injury. So that's the challenge that manufacturers have to do when they're designing new or revised agricultural equipment to prevent an unreasonable risk of injury for that product. Some of the things I'm going to be talking about here are these items in these blocks. All of the things in these blocks that are hanging from the top are things that a manufacturer will do or can do or are doing to help reach a point where they have a product that does not present an unreasonable risk of injury. And I'm going to be talking about several of these, not all of them, but several of them. And there's other things that are not listed here that a manufacturer does and can do. But these are some of the main ones that contribute to a manufacturer's process to determine if things do not have an unreasonable risk of injury. And the first one I want to talk about are industry standards. These are standards that are guidelines for designers of agricultural machinery. There's standards for all manner of different products, but I'm going to be focusing on agricultural machinery standards. There are safety standards that provide guidelines to manufacturers when they're designing machinery, and they help get that manufacturer to a situation where they're addressing potential injuries on machines and designing the machine in such a way that the injury is either eliminated, potential injury is either eliminated altogether or reduced. These industry standards, they cover a wide range of machines. There is not an agricultural machine today that is designed or could be designed tomorrow that there isn't an industry safety standard for agricultural equipment that would cover it. They're put together by working groups, people like me, people like many of you that are on this call, perhaps. Some of you may actually be on a standards writing working group, either at the national or international level, but they're made up of people that have an interest in the subject. And they might be representatives of a manufacturer, they may be a government safety agency, they may be someone that's a staff member on a machinery association. But all of those, that diverse group sits at a table and over a period of months, usually months, hardly ever less than months, is able to develop a standard to fill a gap where one didn't exist. Those standards provide just design guidelines for the designer. They're voluntary, generally in nature. They're not. That group that drafts the standard, that group does not have legislative authority. So the standard that the group drafts and produces does not have the force of law. But in some cases, an industry standard is adopted by a legislative body and made part of a statute or a law. For example, back in about 1997, in the province of Manitoba, the province authorities, the legislative group, essentially adopted the Canadian Standards Association and the ASABE Association standard for lighting and marking of agricultural equipment on public roadways. That was done. They basically took a voluntary standard and brought it into their law and said, this is what is required now. And that happened in Manitoba. In 2011, down in the United States, the US Congress adopted that same standard as federal requirements for lighting and marking of equipment in the United States. And those standards and the technical requirements that are in there, technical guidelines, they're really the minimum that a designer is expected to follow when they're designing safe machinery. Designers can go beyond them, and that's always encouraged. But if you have not followed the guidelines of that standard, you need to really have a good reason if you're a manufacturer as to why you didn't follow that requirement. And they do get reviewed most of them get reviewed about every 5 years for updates or revision, and sometimes cancellation for one reason or another. Who develops those standards? Well, in North America, we have the Canadian Standard CSA group, Canadian Standards Association group, and in line and in league with the American Society of Agricultural and Biological Engineers down here in the States. Those two groups have a long, long history of working together to develop standards for agricultural machinery. And I've been on many, many standards writing groups where there's a combination of Americans and Canadians that are working together to develop a standard. So those two groups, both of them are publishing standards. And then we have the International Organization for Standardization, ISO, that is also publishing standards. And those standards are, again, written by a group of individuals that sit in an international group made up of Americans and Germans and Canadians and French and so forth. And they are writing international standards for agricultural machinery. And the representatives on those committees are coming to the ISO committee representing Standards Council of Canada in Canada, and the Americans are coming as representatives of the American National Standards Institute. But those two groups then work together to publish. They're representing their country, not their manufacturer or their association or their employer, but their country to develop an international standard. Now, CSA has a long history of adopting ISO agricultural machinery standards, and I just pulled up one example here. In the late 90s, the Canadians and the Americans got together as a standard group under ASABE to write a standard and develop a standard for passenger seats or instructional seats in agricultural tractors and self-propelled machines. That standard was adopted by ASABE when it was worked on after a time through a joint Canadian-American effort, and then eventually CSA adopted it as a standard for Canada. So that's just an example of how standards get developed and how they come about and get implemented. That very same standard then, a few years later, was then taken up by an ISO working group and adopted as an international standard so then it grows from being a standard for Canada, United States, into now a standard that other manufacturers around the world would apply to their machine. I mentioned that there is not a agricultural product that exists today that isn't covered by some form of a standard written for agricultural machinery. And here are just some of the categories of agricultural machines that are covered by those industry standards. Everything from agricultural tractors down to grape, olive, and coffee harvesters. These are international standards, again, developed by a consortium made up of representatives from different countries around the world, including Canada. And Canada sits on many of these committees, helping to develop, write, and revise these standards. And that's a real good effort. And the results are a promotion of safety involving agricultural machinery. From a Canadian standpoint, I believe this list is up to date, but if I've left somebody off, my apologies. But from my information, these are Canadian nationals that are currently involved in one or more ISO international standards writing working groups. So you may see your name up there. If I have left you off, my apologies. But for all of those, ladies and gentlemen that are here working on behalf of Canada for farm safety, my hat's off to you. It's not an easy job. It takes time away from your regular duties. It can involve expense, traveling to meetings, then reviewing documents, making comments, reviewing documents again. So it's a good work if you're involved in that. And all I would say to all the individuals here is thank you for being a participant in that, because it is important. So standards development, that's one thing. The next thing we want to talk about is risk assessment. And that is looking at a product before it hits the market and asking, is there anything on here that would present an unreasonable risk of injury? And that's a process that's addressed through a risk assessment process where a group from the manufacturer, within the manufacturer, will look at the product, evaluate it, and see if there are any hazards there that have to be addressed in the design. And those hazards may involve a risk to operators, to bystanders, or maybe even property damage, such as equipment fire. And the purpose of that is to look at the product and evaluate whether there are hazards there that would not be open and obvious to the user of that product. And then if there is that hazard, see what can be done, if anything, to reduce the risk of injury of that hazard. So oftentimes the risk assessment is done most typically during the development of a product, but sometimes a risk assessment is done as a result of an accident to answer the question, well, what happened here? Is there something about the design that we missed? Or is this operator error? Is it something that we haven't properly instructed the operator on, if it was operator error, and so forth? That's another time when risk assessment might be done, is when you get feedback from a user of the product through the dealer or directly to the company, saying, I think there's something here you need to look at. I believe it's a safety concern. And I put up just an example here. I made that quotation up, but that is typical of the types of things that I would see when I was working at John Deere and would hear about accidents or feedback from customers. In Canada, you actually have, through CASA, a real good tool for customers, Canadian farmers and operators of equipment, to report issues that they may have, concerns they have about the safety of a product. I wasn't aware of this until, I think it was Megan or one of the ladies put me onto this, but I looked through this and I thought, this is really great because it's a forum, a portal for an injured operator, user of equipment that might be concerned about a safety issue, and it gives them a place to report that. And then CASA looks at that, and the objective is to pass it along to the manufacturer if that's possible. So that's a good feature of getting customer feedback. This is a typical risk form used by not everybody, but it's fairly common. There's different variations of this, but it's a process where a group will look at a machine, and on the column to the left, they're looking, say, to identify a hazard. And if the hazard is there, then they want to look at, well, how often is the operator frequency exposed to that hazard? And if the operator is exposed to that hazard, what's the likelihood there's actually going to be an injury? And if there is an injury, how severe is the injury? So there's different ratings, numbers. Manufacturers can come up with their own numbers. Manufacturers have variations of this. And in this example, those four numbers that are shown, frequency, probability, and severity, those are multiplied together to come up with a composite number called the risk level. Now, during the risk review, the group that's doing this will have a lot of discussion about these numbers and whether or not there's actually a hazard. And if there is a hazard, well, how frequency? Well, one person might say, hardly ever happens. And another one might say, I disagree. I think it could happen at least every time the person uses a machine. Those discussions take place. They can be vibrant discussions. And ultimately, the people in that having a discussion will work through that and come up with those numbers and then come up with a composite level. When that composite level number is figured out, then the recommendation may be to the design team that this number is too high. We've identified this hazard, it's too high. We'd like you to go back and look at this and ask the question or answer the question, what can be done in the design to drive this number down, to get it lower? The tricky part of this is there is no standard internationally or in Canada or in the United States, anywhere, when doing risk assessments like this to say, well, what's the threshold number? What is safe? And what's the number it has to be or it can be to tell us that it needs to be revised? There is no number. There is no guideline on that. So it's left to the manufacturer to decide what's acceptable or not. Manufacturers will come up with their own guideline internally with what's acceptable. How high can that number be before we need to really be looking at that? But overall, the manufacturers are trying to drive that number down to get that to go lower. The next thing I just want to briefly talk about are safety signs. And safety signs is the proper term for that. There's an international standard for safety signs. There's an American standard for safety signs and a Canadian standard for safety signs. But these are those warnings that are placed on the machine to help guide and alert the machine operator to certain hazards that may be there. We manufacturers operate under this theory called the safe design hierarchy. And basically what that says is the manufacturer, the designer, has a hierarchy of priorities. If there is a hazard with the machine, the first priority is, if at all possible, design out the hazard. Take it away, redesign the machine, so the hazard is not there. But oftentimes that can't be done. So the next thing is, well, if we can't remove the hazard by redesigning this part of the machine, then we need to guard against the hazard so the operator or the bystander cannot come in contact with that hazard. So that's where you get involved with guarding issues and so forth. But also, you get into a point where you can't necessarily guard against the hazard either, and all you're left with is you can't design it out, you can't guard against it to prevent contact, so you're left with warn of the hazard. And that's where safety signs and safety messages in operator manuals come into play, and what I want to talk about briefly. Both in Canada standards and international standards, there's 3 types of safety signs that have text on them. The first one is caution sign, and the second one is a warning sign, and the third one is a danger sign. A hierarchy of alerting the operator. The caution signs represent the least serious level of the hazard. Doesn't mean there can't be an injury, but it's, of all the things that could take place in terms of an injury, it's farther down at the bottom of the scale. And caution signs will give general instructions, maybe several times, to the operator about safe operation of the machine, or they may point to a specific hazard that can't be addressed previously and says, be aware of this. The warning sign is a little higher intensity. That is referencing a situation where a serious injury can take place. In this case, you can see what's going on here. It's an operator has managed, in the pictogram, it's showing an operator that becoming entangled between 2 pulleys that are connected by a belt, a power-driven mechanism. And so that's a warning. And basically the warning is saying, this pictogram is telling you that here's something you should not do. Be cautious. And it will say, stop the engine and remove the key, for example. Actually, I had a case up in Canada several years ago where an operator did exactly this. He had the combine shields. It was on a combine, had the shields open. Combine was running, the belts were turning, and his plan was to use belt dressing and spray it on the belts. And he reached between 2 running belts like this and became entangled. Well, there were warning signs on the machine about that, but still, it took place. The third one is a danger sign. That's the most serious, where very serious injury or death is perhaps imminent if you don't stop what you're doing. And again, this is accompanied by a pictogram that represents what the hazard is and how the injury can take place. You might say, well, how often or how do you decide what warning signs are going to be put on a machine? And there are 4 different cases. The first one is a warning where it's not open and obvious, where there's a hazard there and an operator may not be aware, is unable to be aware that the hazard is there. And here's an example. It's simply saying there's a hazard of checking for leaks on a high pressure hydraulic line, so don't use your hand to do that. And an operator may not be thinking that when I'm checking for leaks on this hose, this hydraulic hose, may not be thinking of the high pressure that's underneath that hose wrap. Sometimes an industry standard will specify that there has to be a safety sign addressing a particular hazard. This one is out of the international standard for all agricultural equipment, but it basically says if the equipment is more than 4 meters high, there must be a danger sign on, or at least a warning sign on the machine that's conspicuous and in view of the operator that warns them against contact with power lines. These types of things actually happen more frequently than we'd like to see with the ever growing size of agricultural equipment and implements. So that's another example. A third example, a little more different than the other 2, the hazard might not be open and obvious to the operator, but the manufacturer's experience has shown that operators tend to be rather casual about the hazard and get themselves into trouble. So if an operator doesn't appreciate the hazard and the accident history has shown that, then sometimes the manufacturer will use something like a danger sign or a warning sign to reinforce the idea that even though you know that this is not a good thing to do, don't do it. The final case is where we look at just trying to warn the user against reasonably foreseeable misuse. And that is a tough issue to deal with. Trying to decide what's reasonable to one operator is maybe not going to be reasonably foreseeable to another. This one, for example, any manufacturer that's dealt with combine harvesters and grain tanks has had issues over the years with operators getting in the grain tank to kick grain free and get it to flow, and resulting in entanglements in the unloading augers inside the grain tank. So is that reasonably foreseeable? Yes, we would have to say based on accident history, some operators are going to try to do that. So a danger sign warning them, preferably in the access path to get into the grain tank right there, saying, don't do this. What you're about to do, stop, because it can either kill you or severely injure you. So those are safety signs. Those safety signs are all covered by a standard. You do not get to pick different colors. The colors are orange, yellow, or red. Caution, warning, or danger, and those are all established by these 4 standards. There's no daylight between these standards. Canada has a safety sign standard. It's modeled after the international standard, ISO 11684. The US has the same standard, model or a similar standard modeled after ISO 11684. Then there is the ISO standard for safety signs, and the ANSI down, at least in the States, American National Standards Institute, also publishes a standard for agricultural or all equipment safety signs, including agricultural machinery. Those standards specify what a safety sign should say, and basically the safety sign should alert people to what the hazard is, how to avoid the hazard, and if you don't avoid the hazard, if you don't follow the safety sign, this is how you can be injured. Might be a small entanglement or a serious entanglement, but that's the content. Manufacturers try to develop these safety signs to cover those points. In the danger, warning, and caution, those are called signal words. Those are the three choices available to the manufacturer. The manufacturer, if doing a proper safety sign, won't use other words like watch out or be careful. It would be either danger, warning, and caution with the colors and associated with the standard. And these are the colors: red, orange, or yellow. They're intended that way to stand out and be conspicuous to the operator so they can not only see the standard, but grabs their attention, see the safety sign rather, grabs their attention, and hopefully then they would look at it and read it. Sometimes, well, in Europe, where there's multiple countries and multiple languages, the safety signs for agricultural machinery are almost universally text-free. This type of standard, this is called a text-free safety standard. It's also covered by the ISO 11684 and the other standards that I talked about, Canadian standard and the American standard. But it specifies how to do a language neutral, meaning no text at all, safety sign. And they're always in yellow, always in two panel, with the top panel, or if it's horizontal, the panel to the left showing what the hazard is, and the bottom panel showing how to avoid the hazard. These are pictograms that are identified in the standard. The manufacturers may have to create their own from time to time, but generally there's a pictogram, a hazard pictogram, and a hazard avoidance pictogram that will specify what the issue is. You might look at that and say, well, how is someone supposed to understand what that means? Well, the key here is that these safety signs and the pictograms are relevant to the type of machine that a person is using. So a common operator is likely to understand in the first pictogram at the top that it's talking about thrown objects coming out of the back of the machine or the side of the machine, and the sign below would as accepted as a common sign, which simply means keep away or stay clear. Back to language safety signs, sometimes manufacturers will use two languages on the same safety sign. That process or that format is not addressed in any of the standards, but manufacturers sometimes take the initiative to do that. The safety sign on the left is from a manufacturer of equipment in California that's used to harvest different types of nuts, pecans, pistachios, and so forth out in California, where many of the workers are Hispanic. And so that manufacturer puts the safety signs on the machine, both in two languages, English and Spanish. And that's a good feature. Up in Canada, at least in Quebec, you have the Charter of the French language, preservation of the French language. So a typical manufacturer that's putting a product in the province of Quebec will make the safety signs that are on the machine available in the French language, and that's what I've shown here. Manufacturers will either overlay the French translation onto the existing English safety sign, but most typically they'll put it next to it. But that's an effort by the manufacturer to comply with France's or with Quebec's national law. Focusing again, moving into the operator manuals now, that's an important part of operator safety. The operator manual, the content, form, and layout of operator manuals are also covered by an international standard. This particular standard, ISO 3600, is the international standard for form and content of operator manuals for agricultural and forestry and lawn and garden machinery. And it's been adopted by CSA as a national standard to follow, but it covers inside the standard what is the minimum expectations in an operator manual. For example, that standard will specify that each operator manual should have a section devoted particularly to operator safety. And here's a typical page. This is out of an operator manual that I have, but it's caution messages with some pictograms reminding the operator what to do for safe operation of that machine. The same standard also specifies that if there are safety signs, when there are safety signs, either caution, warning, or danger on the machine, they need to be shown in the operator manual where they are found on the machine, and they need to be in legible form so the person reading the manual can understand what the safety sign is. Why is this? Well, it's another way to reinforce with the operator the safe operation of the machine by pointing out the safety signs as a reminder of what to do in safe operation of the machine. And secondly, if a safety sign becomes torn off or worn off or is no longer legible, the operator can use the manual to go back and do an inventory and say, what was this sign here? I can see a piece of it, but I don't know what it was. They can go to the operator manual, find what that sign should say or did say, and then go back to the dealership and get a replacement. And the manual further states that the manual needs to include information about where the operator of the equipment can go to get such a safety sign. Whether it's a dealer or it's a number or it's a website or whatever, that needs to be included in the operator manual, all for the purpose of helping the operators or the owner of equipment to keep that machine in good shape, which includes keeping safety signs on it. This is a standard that I just want to talk about on the international side. This is an international side for that, or this is from the International Standard for Agricultural Machinery, and it addresses operator manuals, and it specifies in self-propelled machines that there needs to be a storage place on the machine for the operator manual. And so that would be something that the standards writing group discussed and came up with. And its purpose, of course, is to keep the operator manual with the machine so it's accessible to the operator and it's not left in the machine shed or in a desk drawer in the shop office or whatever. But this is just another example. But the idea is putting focus on operator manuals and specifying that they need to be kept with the machine. That's where we want them. And to facilitate that, we require in this standard provision. Now, there's a search situation that's coming up on operator manuals. And this is over in Europe. Currently, under the regulations for the safe design of machinery in Europe, operator manuals have to be in paper and they need to be provided with the machine. That's just a mandatory requirement for every country of the European Union. But that's going to change. That is going to change in 2027 in January when a new regulation takes over, replacing the old. And the new regulation now gives manufacturers an option of providing digital operator manuals. Manufacturers can provide paper operator manuals, but they will no longer be required to do that. They will be able to tell the operator where you can download the manual digitally. And so it's a big question from me, from a safety standpoint, how that's going to work out. I know myself, I'm old school. I don't particularly care to download operator manuals after I've purchased a piece of equipment. I would rather have the manual with it. So how is this going to work out in the future? The answer is unknown. The requirement is that if the operator wants a paper operator manual, the manufacturer has to make it available to them. But it's going to be a question how this works out. With younger farmers that are totally comfortable with technology, this may be the greatest thing since sliced bread. But we just have to see how that works out. The last thing I want to cover real briefly are safety committees. These are groups sometimes called safety committees, sometimes called management groups for safety, different names, but they are established not in all manufacturers, but many do now. They provide oversight and they're looking over the work that's going on the safe design of the machine. They're asking questions, they're reviewing accident reports, asking the question, is there something we can do about the design that prevent this accident from happening again? Those groups are a place where a product safety engineer or a design engineer that might have a concern about something on a machine can take it to and have a group fully discuss what the issue is. Now, as I said, not every manufacturer that you're going to come across is going to have a group, but I believe from my experience now working with other manufacturers outside of John Deere, most have something. They may call it a different thing. They might be a subset of the regular management group, but these are groups that are looking over the safe design of machines and asking, are we doing the right thing? Are we taking the steps to prevent unreasonable risk of injury? Over the years, there have been a lot of improvements and innovations in that support the safe design of machinery and are intended to drive down accidents. Here's a few of them. There's many more. But some of these, all of these have had an effect on reducing farm injuries. And there will be more to come, but you can see them here. You might have a question about this one or that one, but all of them originated not from some legislative body or some provincial authority, but each and every one of these originated from a manufacturer or a consortium of manufacturers that said, we need to do this, or we should be able to do this, so why don't we do this? And all these things listed here are now covered in one way or another in either national or international standards. And it just shows that manufacturers have a vested interest in reducing the possibilities of farm injury. And doing that in many ways starts with the design of the machine and innovations of those machines. So you might see some things on there. There's going to be more. There will be more coming. As we look at going from here forward, what are the challenges? Well, for manufacturers, in my mind at least, the biggest challenge is going to be addressing safety of emerging technologies. What am I talking about there? You may or may not know that manufacturers, ag equipment manufacturers now are placing equipment on the market that's fully autonomous. John Deere, for example, has one of its tractors that the operator can operate the tractor from his cell phone, from his office, or from his kitchen table. And the equipment is operating in the field with no operators on it or around it. That presents safety challenges. Manufacturers are addressing those, but there will be other innovations that will challenge manufacturers. And for CASA and ACSA, the challenge is to continue to promote farm safety and doing what you can to get the message across to farm families, farm operators, equipment operators, get the safety message across to them with the idea of reducing farm safety. There's a culture out there in the farming community that is hard to crack. I was raised in that culture. When I think about all the unsafe things I did when I was on a farm as a teenager, I shudder to, I thank the good Lord that I'm still walking around and have all my limbs. But there's a culture on the farm that's hard to overcome. It's a place where people live in the same place where they work, unlike being in a factory where you work in one place and you go live someplace else. But CASA is doing a good job trying to get the message out and to promote farm safety. And so for CASA and Canadian Canola Growers Association and other farm organizations that are working on safety, my hat's off to you. So with that, I'll just open it up. Megan, do we have any questions or anything that I can answer?
We do. Yeah, thanks so much for that presentation, Mike. That was great. So we do have one question from Peter. He is with the Canada Energy Regulator Damage Prevention, and he does not see any warning signs or standards that were discussed on the safety of farm equipment that create a ground disturbance around pipelines.
Okay. Um, yeah, good point. So the question is the industry doing anything about safety from contacting ground buried pipelines? Is that basically what Peter?
I believe so, yes.
Yeah, good question, Peter. So that it may be being addressed by the ISO committees that are working on field implements, uh, chisel plows and so forth. Those are included in an ISO standard, and they may be discussing that. But the way that works typically is someone will raise the issue and say, "Don't we need something here?" And that if that goes to the committee, then the committee has a discussion. Should we do something about this? Is there an opportunity to write a standard? Is this something, a risk that is going on addressed? And if the group decides, yeah, it's a valid issue, then that starts the process of developing a standard or a revised standard. So it's a good thing. The best thing if an individual has a concern is to raise it with your Canadian Standards Group, Canadian CSA, and see if that can be taken forth by the appropriate individual to a standards committee.
Sure. Carl had a bit of a follow-up to that, saying it's out of scope of ISO 11684, and he believes it's more of a workplace safety issue. So thanks for that,
Okay.
Carl, and thanks, Craig, for asking the question. It was actually Craig, not Peter. Sorry about that. Does anyone have any other questions or comments? There's lots of thank yous, Michael, in the chat for you. Everyone really appreciated your presentation today. It was very informative. Any
Well, I
other
hope
comments?
so.
It was great. I loved it. Okay, so seeing as there is no more questions, I think we will wrap up for today. Thank you guys so much for attending, and thank you so much, Mike, for this great presentation. And a reminder to everyone, it is Canadian Agricultural Safety Week, so please visit our website to learn more about what we are doing and to help us celebrate by sharing the posts on your social media accounts. And reminder to be safe every day. Thank you again, and have a great day. Bye-bye.
Thank you, everyone.